So if you want to become a better designer, here's a couple of tips that are going to help you get along that road. Just a little background. For me, I didn't even know any of these machines existed. I was designing for them because I had no other alternatives when I lived in Korea. So what I was doing is I was imagining a machine that can do what these machines are doing, and I taught myself how to design for them that way. And then when it came to being that, hey, these CNC machines actually exist, well, wow, everything sort of works and everything clicked perfectly in my mind for that. Now, if you want to learn how to design, the number one thing is you need some experience in the shop. I started off completely digital, so with pixels and whatever was in my head. And that's how I learned how to design for CNC machines. And it wasn't until, 5-6 years later that I actually got to touch my own real physical CNC machine and actually be able to test my designs on an actual platform. If you want to speed up ahead, that's the first thing you do. Get a little CNC machine. I don't care if it's a 3D printer that you bought for 200 bucks. Just design for that printer and they'll teach you all the basics you need that will make learning how to do CNC routering, plasma, laser, all that stuff. It's all basically the same machine. There's just different tolerances and curves involved. But once you know how to design for one, you could design for the other ones. Pretty straightforward. The other thing to keep in mind if you want to become a really good designer is learn materials. Especially for architects. I don't know why, but they're completely oblivious to materials and they try to suggest things just don't work together. So for instance, half-inch plywood. Half-inch plywood is never half an inch thick. You might get 5/8 plywood, that's not 5/8 thick. So if you're designing something where your tolerances are very, very specific, that just won't work. Another material that comes to mind is corian. You can only get corian in two thicknesses, 5/8 and half-inch. That's it. Let's say you have a design that means you want 1.25 inch corian thickness. Well, guess how you're going to do that? Well, you're going to laminate it 3 layers together, so half-inch, half-inch, half-inch. Then most likely what I would do is use a CNC router to flatten it down to 1.25 inch. Now, another thing to keep in mind if you're a designer is that whatever designs you make in the machine, those are not real. And what I mean by that is you could defy the laws of physics very easily in a CAD program and make things that work together that absolutely do not, especially when you're mixing materials. And then when it comes to real life, you're like, hang on a second, this doesn't work. The thicknesses that I assigned don't work with this and this and that. And that's why I say if you start off, just get yourself a small little CNC machine for a couple $100 and learn that aspect of the design. It will make you a far better designer in every way. Another thing that I deal with quite a bit with designers is they have a vision of one specific machine to do the whole project. So maybe, a long time ago they saw a CNC router, so that's all they have in their mind as to how they're going to make whatever they need made. So yeah, you're a designer, you can design stuff, but it doesn't mean you can fabricate stuff. So let's say you have a stainless steel. You want to cut it with the plasma, you want to cut it with the water jet, you want to cut it with the laser, you want to cut it even with a router, depends on the specs, or a CNC mill. Those are 4 different machines that can cut metal. Some of them are better, some of them are worse. They all have different curves involved with them. They all have pluses and minuses when it comes to fabrication. So let's say if you got a especially thick piece of metal, you might even just go with oxyacetylene cutting. So there's another one, right? So there's a lot of different ways to do the same thing. And part of my job is to tell the designer, hang on a second, you want this done with this machine? No, actually what you should be doing is cutting it with this machine and here's why. And you just list them out. And generally they don't argue with me because they know what I'm doing. Another thing to keep in mind if you want to become a really, really good designer is you have to be open to new ideas. And again, back to the architect thing. I don't know why, if you're an architect, you have to have a closed mind on how things are made, and they have to be made with materials that just don't work. And I deal with that all the time, and it's frustrating, and that's just part of this kind of business. But designers also have to have an open mind. You might be dead set on using, 5/8 acrylic for a certain application outdoors. Well, that's a horrendous material to use outdoors. You can't get 5/8 acrylic. You can't create materials in your head and tell someone like me to make something like that. It doesn't work that way. And another thing to keep in mind is volumes. The more same material you use for your project, the more cost effective and the faster the turnaround. There's no point having a project made where you need 150 different materials and they're all like small little pieces like this. It just doesn't make sense, efficiency-wise, cost-wise, every other wise that's possible. So if you're looking to become a really good designer, I'd also suggest you take welding classes. Now you might say that's kind of strange, it has nothing to do with CNC. It does, especially if you're doing metal work. What welding actually does is it focuses your mind to see how tolerances sort of meander when you're making something. So let's say you're making something long like this here, and you're starting to weld here. Well, you can't do a complete weld all the way across, because then it's going to warp like this on you. But the same holds true for other materials. You got to keep in mind that whenever you fabricate something, there's pluses and minuses to every aspect of it. And whenever you machine something, you're always modifying the material. So if your tolerances are like, this needs to be within 100 thousandths, good luck with that. You're going to pay a fortune for it, because I need probably to make 150 prototypes, and only one of them will, by chance, meet that spec.